Welcome, I'm MC Toon, the worst rapper in the world. Today I have with me a special guest who's been on my stream, not on my stream, on my channel, talking in the comments and everything for a while. I have Hop Hippie. How you doing, sir?
Pretty good. Pretty good.
Oh,
What's up, everybody?
I think I
What's up,
nailed the
MC2?
audio this time. So yeah, good to have you. It's been we've had this scheduled out for a while, and Johnny B already with $5. Thank you very much. I love your style, MC Tune. Hello from Minnesota. Well, hello back from Minnesota. Be fun to. I think like maybe we should do like a in-person debate some week, and invite everybody around here. So, how you doing, Hip Hop Hippie?
Doing good. Doing good. Loving life.
Yeah,
Just want to say hi to my girl. She's in chat, maybe. Um, I love her, and
maybe. What
just want
if
to
you
say
don't mind? What's her name in the chat so we can all say hi to her?
her name is Dandelion.
Dandelion. All right. Oh, I think I knew that. I think I heard you say something about that before. So, mods, be nice to Dandelion. All right. So
Yeah.
we were.
Also, I just can I just say what's up to all the agents in chat that hate me, all the haters. Don't worry, it's okay. I'll be here for you when you realize that the globe is dead. I'll welcome you with open arms. The grass is greener on this side, so come on over.
Nice. So, we were just talking about the conference in Colorado that was a couple years ago, and about whether or not you went to that and what you thought about it or what maybe happened.
Well, yeah, we were talking about how I live in Colorado, and we're talking about how long I've been a flat earther, and I met my fiance in a flat Earth chat, and she lives in Australia, so Australia exists. But because I live in Colorado, we talked about going to the conference, but she wouldn't let me go because she loves me and she didn't want me hitting on other flat Earth chicks. So
So, so I was at the one in Texas, and if the attendance there was anything indicative of what was in Colorado, there was nothing to worry about.
oh.
So,
Yeah, no, she was awesome. I love her a lot, and she's great, and sh it's just a funny story. It was just cool,
yeah,
but she's great. It was just a joke. So
good, good. So, yeah, a flat earther from Australia, of all the strange things. So, maybe she could measure the angle of the sun on the test the curve day that Billy Zig
um,
is talking about. So
yeah,
anyway, yeah,
maybe
maybe we get into
for
that
sure.
later. So all right, what do you think? What do you want to start? You want me to start?
Um, uh, well, I just want to make this clear. Like, I'm a bumpy earther. I roll with the flat earthers, but I don't really like I don't really know what shape it is because I haven't been high enough to
Bumpy.
see like the full Earth. So it might not even be a shape. I don't know. I have no idea what it looks like. All I know is it's bumpy and the horizon is horizontal, flat, plane. So that's pretty much what I believe. I don't know if there's a dome. I feel like we're contained, but I don't know if it's a dome. No clue. Um, don't know where the edge is. Don't know if there is an edge. No idea. All I know is it's not a globe. So,
That's what you know. All right. So you know a
yeah.
knot. So all
Yep.
right. All right. So is
Well,
there?
at
Do you
least, at least the globe, at least the globe for your dimensions can't exist. So,
can't exist? Okay. And so how is
yeah,
that?
it's been debunked. The Black Swan debunked it. Uh, if you want to go into that first, that's always a
Sure.
good
That's
go-to.
so the problem with that, of course, is it's a pretty poor observation because they didn't take the conflating variables into account.
Um, like what?
like refraction. Refraction's a big deal. If there was no atmosphere, then it would be a lot easier to measure these things. But since refraction happens, there is definitely effects that it causes. So I can. So it changes. It tends to raise distant objects up, so they're higher. I can show you how that happens. Here, let's see. There you go. It's on my website. How does downward refraction affect what we see? So here you go. Downward refraction. So light bends as it goes from one medium to another, or one area of index of refraction to another. And that's Snell's law. Right? Are you familiar with Snell's law?
No.
But it's okay. It's why glasses work. It's why camera lenses work. People have a pretty good understanding of it. So when light goes from one medium to another, or one index of refraction to another, it bends towards the denser index of refraction. So in our atmosphere, down close to the ground, air is more compressed and denser, and the index of refraction is higher than at altitude. And that's a consistent gradient all the way up from the ground to where there's basically no air left, and the index of refraction is 1, and down near the ground it's more than 1.
Okay. So what are you saying is wrong with the black swan image? Can you put that up just in case people don't know?
Yeah, I can.
Like, do you happen to have?
Sorry, still.
So you know the argument, right?
I do. I know the argument, but the problem with the argument is that it discounts the effects of refraction. So I'll pull it up, and then I'll go into Snell's law. So I think I have just a still.
Well, do you know the modus tollens argument for that?
Yep.
Picture.
Yep. And I'll get it.
Can you state it for me?
Yep. Just hold on. I'm focusing, man. I'm trying to get. All right. So I don't have the best one. I have the one from BLMS, whatever the guy's name is.
Yep.
I'll put that on. Right. There we go. So there it is, and then I'll share that to you so you see it. But I gotta pin you. There you go. All right. So now you should see what I'm showing, right? So we've got on the right, on this inset on the right, and inset, both of the insets actually. The inset on the left, I think, is the one that's the most commonly used version of it, where it's at 1 foot elevation, right? And you can see, and I'll zoom in on that one a little bit. You can see the bottom of both of the oil platforms, right? And now the important part is that you can see the this crane. Now I've seen some where people go and crop out this crane on the left side, but you can see this crane, which is straight. It's physically straight, but in this image here, it's severely bent, right?
But the argument's not about the oil rigs, though.
No, I understand, but the point is, of course, that refraction, and that's very important. Refraction is happening, and it's a pretty extensive refraction happening, right?
Yes, but what are you saying is refracting? The horizon?
Everything is refracting, yes.
Okay, but see, in your model, the horizon, the geometric horizon, would be in front of both of those.
And that's not a problem, because we don't see the geometric horizon unless there's no refraction happening. But since there is refraction happening, we see a modified version of everything. So I was saying, the refraction in normal states where it's more dense or it's a higher index of refraction down low, reducing as you go up, it will raise everything higher up, including the horizon.
Well, if the horizon is in front of the oil rigs on your model, because that's where it's supposed to be, how does it refract behind the oil rigs? How does it go through the oil rigs to behind them?
Because everything refracts. The light that bounced off of the water refracts just like the light that bounced off the oil rig. Everything is.
But in your model, the horizon must be 1.225 times square root
the geometric horizon. Yeah, but in my model, refraction affects the view of the horizon.
Yes, but what you're saying is the horizon's being refracted. It's like you're saying the horizon's like a ghost, like it goes through the oil rigs to behind the oil rigs.
Everything
That's
is refracted.
Impossible.
So what happens is it effectively changes the radius of the Earth is how it's done, right? So if the radius is like this, when there's refraction, the radius is like this, and when there's more refraction, the radius is like this, right?
The radius can't change on your Earth. It's set. It's set in stone.
Not the physical radius. I'm talking about the apparent radius. So when we calculate the so there's the index
radius.
There's absolutely there. It's
so wait a second. How is the radius apparent? Isn't that set in stone?
No, not at all.
Your radius is 3959 miles.
Yeah, that's the geometric radius. But when the light is refracted, it affects our view of everything, and so we use a different a multiplier of the radius as an approximation of what we should see. So when we look at and it's actually in the what's called the coefficient of refraction. The coefficient of refraction speaks to the actual radius of the ray of light as it travels from the object to the viewer.
Okay.
Right?
Okay, but for it to be refracting, it has to be refracting around the horizon, right?
Absolutely. Yes.
Well, see, the horizon is behind the oil rigs, though.
Yeah, and it all is refracted. Everything is refracted.
No, it's the horizon. What kind of refraction is it?
It would be
in that photo.
In that photo, it would be a refraction that is a positive coefficient of refraction.
So what's the name of it? Is it looming? Are you saying, because Fight the Flat Earth says that the horizon is looming, and when you
sure if you want, so when people do put categories, they're artificial, but it's just a way to have a conversation about it. They'll put names on different types of effects that they see, right? So yeah, they will say it is looming. So yeah.
So do you know the modus tollens argument for this image?
The modus tollens speaks to the geometric horizon, which
if the Earth is a sphere with a radius 359 miles and every horizon distance measurement, because your horizon is geometric.
No, that's your assertion. That's not my model.
It must be. Must be. It is your model. That is your model.
No, it is not my model that we only see the geometric horizon. Dude, you don't get to tell me what my model is, dude.
The horizon. So what are you saying?
Modified.
Are you saying the horizon is refracted?
Absolutely. I said that again. That's the second time.
So it's not geometric. So that horizon right there is not geometric.
We are not seeing the geometric horizon.
Is not geometric, right?
Correct. Yes.
In the Black Swan.
That's
right. Not. Well, can you show me the geometric horizon then?
No. Only if there's no air. Because there's atmosphere. It modifies everything that we see.
Then how can you say boats and ships are going over something that's not there? It's not real. It's an apparent horizon.
The view of the boats and the horizon is all modified.
So is the horizon not the curve?
The horizon is the curve, yes. And we see a refracted, modified version of it.
But the horizon is apparent.
Yeah.
The horizon is always apparent. So it can't be physical if it's apparent.
Well, it can be physical in that it's geometric. right? But that's not what we
Well,
see.
it's not.
We see only the light that
Well,
comes
then
to our eyes, and the
so
light
it's
that
not
comes to our eyes
geometric.
has been, yeah, third time.
So it's not.
That's right. It's not
So
the geometric horizon that we're seeing.
well, I agree with you. There is no. It is not the geometric horizon that you're seeing because no horizon is geometric. It's always apparent.
That's right. Okay, so we can move on then.
So
We're in
yeah,
agreement.
that debunks your globe.
No, it doesn't.
Yeah,
Not
I
at all.
agree. Yeah,
It completely matches
you
because
need
all right. So
no,
let's
you
let's
need
go
a
back.
geometric horizon. You
No,
need a geometric horizon,
no,
and
we
that's
don't.
not
All
a
right,
geometric
so
horizon.
let me show you here. This is zoomed in way too much.
The
Here
horizon
is
is never geometric. Can you show me a definition where it says the horizon is geometric?
why are you trying to put that on me? That's not my model. All right, so here's
Well, you
how
just said the horizon is your curve, though.
it is the curve. Absolutely, yes.
The
And
geometric curve.
it but what we see is the apparent curve. This isn't really that complicated. So all right,
So
no,
okay,
hold
so
on.
if you're seeing the apparent curve, how do ships go over something that's apparent?
They are
That's
apparent.
not
So
physical.
the light on the other side of, let's see. Oh, here I have my unplugged in echo here. Let me make it bigger. So we've got right here the right. So a viewer here, right? They see, and then there's something over here, right? They only see what the light can get to, right? So if there was no atmosphere, there'd be no refraction problems, and we'd just see what we see without any modification. But since it's modified, the light gets the light gets to curve farther around the horizon than otherwise. So we see farther than normal.
So the light refracts around the horizon. It doesn't refract the horizon.
It refracts everything, including the horizon. See, the horizon isn't immune. There isn't anything like special about the horizon that causes it to not be refracted, right?
Well,
Do you think that there's special properties of the light that bounced off the water versus that bounced off the oil platform? No, of course. It's the same light, the same properties apply.
see, what you're saying is your geometric horizon is supposed to be in front of those oil rigs. Okay,
you keep bringing up geometric, and that's not what I'm talking about. We don't see the geometric.
you
We
have-
see what's apparent.
well, then you're not seeing the geometric horizon. So you're agreeing
Fourth
that you're
time,
not seeing the geometric
we do
horizon.
not see the geometric horizon. Of course not. Austin
Well-
Whitsitt couldn't get past this either. He kept repeating.
Then how do you know it exists? Then how do you know it exists?
Because
if you don't see it.
Because we have quantified the effects of refraction, and in regular circumstances, not extreme
Refraction
ones.
exists.
In regular
Refraction
circumstances,
exists. I'm not
hold
denying
on.
that.
You asked the question. I'll answer. We quantified it, right? So lots of people have done tons and tons of research where they'll take, and you've watched my streams, you know this. They'll take two theodolites and they'll point them at each other over some distance, over some particular medium, at some elevation. They do it all sorts of different circumstances.
But it's not geometric though. It's not geometric horizon.
Hold on, let me say this. They'll measure the temperature at both sides. They'll measure the ambient temperature, the daily, all sorts of things that they'll do. And then what they do is both of these theodolites point at each other and measure how far up and down they have to turn in order to see each other. And so if the light is bending like this, they both have to point up in order to see the other theodolite. And so then they know the radius of that arc of light from one theodolite to the other, and they call that the coefficient of refraction. It's just it's related to the measured radius of the Earth. So it's a coefficient of refraction of 0 means it's straight, which would happen when there's no atmosphere or if there's particular conditions. A coefficient of refraction of 1 is when that arc of light has a radius of about 4,000 miles. So people have measured that.
So is the horizon the curve of the Earth?
Yes.
But it's apparent.
Yes.
So
there's
it
nothing
can't
wrong
be the
with
curve of the Earth.
There's nothing
It
wrong
can't be the
with
curve of the Earth if it's apparent.
And how do you support that claim?
Because it's apparent.
So
It's not physical. How can something that's not physical be a curve?
because what still happens though is the light that was on the one side that wants to get over to your eye, it can't get there because there's something blocking it, right? Even though it's curving and it's refracting, there's still too much curve in the way, right? So something too far back still doesn't make it. It still gets blocked on the way, right? So it's normal and it's understood and it's all part of the model.
No, it's not. You're supposed to have a geometric horizon. That's what all your curve calculators are based off. A geometric horizon.
In fact, they are not. All of the curve calculators that are any good include, and I'll pull up my favorite one here, include refraction. All of them. And so you'll see here let me go to English instead of Russian.
What you're saying that the geometric horizon is being refracted from in front of the oil rigs to behind the oil rigs.
The light from the horizon is refracted. So if you look here, if you see here at this one here that says no refraction, and then weak.
Yeah, you see where it says X right there? You see where it says X right there? That is a geometric horizon.
X. What do you mean X? So when
he's looking down, you think you're looking down at the horizon. That is a geometric horizon right there.
Yes, it certainly is. But you
don't see the geometric horizon.
You
don't see it.
So unless there's no refraction, which of course doesn't happen. So if you look here, we're weak 1.13. That is a number that is useful for high elevation measurements, and it was experimentally obtained by Gauss in Germany quite a long time ago. He did lots of measurements to determine how much refraction affects it. And then you got standard 7.6, which some people call standard, but like the U.S. Meteorological Society uses 1.13, which is 4/3. So there's a disagreement on what would be standard, right?
So you don't have a geometric horizon.
Fifth time. You're on loop, dude. Stop saying that. All right, hold on. I'm almost done here.
Do you have a geometric horizon? Do you have a geometric horizon?
Sixth time, we do not see the geometric horizon. All right, I'm almost done here. Hold on. Strong refraction, 1.5, right? So there's a range, and then polar would be something that happens like on a lake in the winter, right?
You say ships go behind a geometric horizon.
They go behind the apparent horizon.
No, you say the geometric horizon.
When did I say that?
You need a geometric horizon. How can a ship go behind something that's not real? It's apparent.
Because it still blocks the light. It still blocks the light. So, all right, let me do this.
So you're saying ships go into refraction, the apparent horizon.
The view of a ship is refracted, just like.
So you're saying ships go into the apparent horizon and not over it, because it's not a physical curve.
Is that what you're saying? It sounds like you're trying to kind of mix things up here a little bit. Here's what happens.
Do ships go over the physical curve or not? Do they go over a physical curve?
They do, but we don't see the physical. We see the apparent. We only see.
How do you know it if you don't see it? How are you saying they do?
Hold on. You're asking a question. I'm answering. I'll answer the question. Okay. We only see what light has come to us. And all the light that has come to us has been modified by refraction. So its effect is that it makes the radius of the Earth appear larger. That's what the coefficient of refraction talks about. That's what it does. And this is measured, and this is known.
So it moves up and down. So it moves up and down.
Yeah.
Right? That's what you're saying?
It does, depending on the conditions. Yeah.
Oh my God. And that's impossible. That is impossible.
But it's
on your globe. That's impossible.
But it's not. Here, let me show you.
It is. It is. It's not now.
Do you know LK?
Well, I guess anything's possible.
So here we go. I will show you. This is LK. Let me get a little bigger here. He has this bottle here, and you see over on the right side the red slimline letter with those two little pieces of clay that he put on there. So I'm going to skip ahead. What he's done is he's put it into the water. I should back it up a little bit. So before he puts it in the water, you can see that he's twisted the stuff out of the way, so you can't see the little clay and you can't see the red rectangle. Right, now he puts it in, and you can see, I don't know if you can see it on your phone or not, but you can clearly see that the I'll put it in the chat here. There, you zooming in. The clay is visible now. It's brought the clay into view. But just a second, though, he shows a little more. You know, actually see the surface of the
Yes. You're not representing your argument, though, because you're saying that the horizon is being refracted above the other horizon.
Yeah.
You're saying
just a second, you'll see.
There's only one horizon, though. If it's refracted, it's not geometric. It's an apparent horizon.
6 times.
It's not geometric.
That's right. You're not seeing the geometric horizon.
Well, then
you're
welcome
seeing
to
the
flat
refracted
Earth, man.
horizon.
It's not geometric. The horizon is not geometric.
You're seeing the refracted
welcome to
horizon.
flat Earth, bud.
So here we see. All right, what's he doing here?
Welcome to flat Earth. I agree. The horizon is not the curve. It's not a geometric horizon. I agree. Welcome to flat Earth.
The problem is that things are still obstructed, which there's no model for.
Yeah. You think things are being obstructed because you think things are going over a curve. But as you just said, it's not a curve.
Right,
it's an apparent horizon.
All right, so now we can see here.
It's apparent.
You can actually see the surface of the where that red slim line is. That's refracted out, or refracted in. Sorry, it's turned so that you can't see it, but because of the water, you can see it.
No.
So he has replicated the horizon being refracted into view.
No, he's not. What you're saying is you need to take that piece of clay and you need to put it in front of the whatever you're trying to make a horizon right here.
Yeah.
Okay.
So
put that piece of clay in front of it, and then when you put it into the water, it's supposed to refract behind the clay. That's what the black swan. That's what you're saying is happening.
That's exactly what we're looking at here. Yep. So
that's not exactly
before it was in the water, you could not see the red, and you could not see the clay. But he puts it in the water, and you can see the red and the clay both. So what's happened is the horizon of that bottle has we can see farther. It's refracted the horizon to us.
No, you're confusing this. You're not getting this right. You need to put the clay in front of the horizon. No, you need to put it behind the horizon and then put it in the water, and then the horizon will refract behind the clay. That's what you're saying is happening. That's what you're saying is happening on the black swan.
So
you're saying the horizon is being refracted behind.
All right, so here's the bottle. Do you see the bottle?
Mm-hmm.
Okay, do you see the red? Not the one in the front there, the one on the right. Do you see the red on the right?
Yep. Oh, no, I don't.
No, we don't.
Sorry.
Do you see the clay on the right?
Nope.
And when he puts it in the water, what do you see now?
You see the red and the clay.
There you go. Just like Black Swan.
It's not, though, because you're saying that has a geometric horizon. You're saying that the horizon is never geometric because you can never see it.
I said we don't see the geometric. We only see what's been modified through the air. So this ships right here
go behind. You're saying ships go over an apparent horizon.
Yes.
How could ships be going over something that's not physical?
Because it goes with it, right? And when there's stuff blocking, you can't see it. Right? So the key is, and this is what QE is talking about and lying about. He says, because he tries to get pedantic about the definition for looming, because it doesn't include in the definition the specific words that the horizon could loom as well. So he thinks that he's going to get pedantic and use that as some sort of an absolute gospel claim that the horizon does not get loomed. But of course, there's nothing special about the light that bounced off the horizon. It gets refracted as well.
Things get loomed. The horizon doesn't loom.
And
things
that's the
loom
claim
to respect
that this right here is refuted.
Let's get up the definition of looming then. Let's read it.
But I just said that my point is that we don't need to look at the definition of looming, because it's not the definition that tells us what happens. It's what happens that tells us what happens, right? The definition of looming is just something that people use to have conversations about it. It's not the rule. It's descriptive, not prescriptive, right? It doesn't have to follow that. It's just what we use to have a conversation.
Yes, it says with respect to the horizon. It doesn't say the horizon looms.
Okay, you're going back to the definition of it.
But what you're saying is some object on the horizon can loom.
And the horizon can loom, absolutely.
No, it never says that. It never says that.
But I don't care what the definition says. I care what we can see right here.
Then you're not using it right. You're not. Then
okay, then let's just dismiss the usage of the word looming and instead just look at the models for refraction.
Okay.
Right. So
also you also know that the horizon is apparent. It's not physical, because as you ascend, the horizon rises with you.
But not enough. But
yes, it does.
Just a second here. I will pull up. Let me make sure this is the... Oh, yeah, there we go. So here is some modeling of by Andrew Young from not South Dakota State University, but San Diego State University. You can see here he has these curved lines here, and you can see that they're bending, right? So you see -1, 0, 1, 2, 3, and different amounts of bend show you different amounts of looming, right?
Bend with respect to the horizon. It doesn't show the horizon looming.
Yeah, because none of these are showing
the horizon doesn't loom. No, because you only have one horizon. Okay, if it was looming above the other horizon, the geometric horizon, you would have two horizons.
No, not necessarily.
You don't have two horizons. Yeah, you're saying that there's two horizons.
I didn't say.
You're saying there's a geometric
horizon.
Only
see
and an apparent
what
horizon.
We see. Right.
Yeah, we see an apparent horizon. We don't see a geometric horizon.
Yep.
Also, why is the horizon horizontal?
It's just a word, man. That's not prescriptive. It's descriptive.
Why is the horizon horizontal?
If you're going to go with semantics, then I'm going to say atmosphere. Right. It doesn't prove anything.
Makes it horizontal. What does horizontal mean? Do you know what horizontal means?
It means the limiting curve. That's the Greek for it. What's the Greek for
right here?
Look at the Greek.
The horizontal, parallel to the plane of the horizon at right angles to the vertical.
Ooh, what's the vertical? How do you measure the vertical?
Vertical is 90 degrees. It's 90 degrees off the horizon.
But how do you measure the vertical?
I don't understand the question. No.
How do you know what vertical is? What's vertical?
What does horizontal mean?
It's tangent to vertical.
Parallel. Okay, parallel to the plane of the horizon at right angles to the vertical.
Yeah. So if you got your vertical, right, it's horizontal to it.
Now horizontal. A horizontal line, plane. Okay, what is so if
right,
horizontal
line? You're getting off track.
No, why is the horizon horizontal?
Because that's what we see.
So we see a horizontal line, plane.
Yeah.
Right.
So
what does plane mean?
Yeah, but you need to now show measurements that the horizon is flat, if that's what you're going to be claiming here. You don't get to just use words. You're going to need to show some measurements.
I'm asking you why the horizon is horizontal.
because that's what you see when you're on the surface of a sphere.
So we see horizontal, a horizontal line,
Yeah,
a plane.
a limiting line.
What
That's
does
what
plane mean?
we see on the surface of a sphere. So the plane is orthogonal to the downward vector, or
Okay,
the vertical
I have
line.
a definition. I have a definition of plane right here.
Hmm.
A surface in which, if any two points are chosen, a straight line joining them lies wholly in that surface. A flat or level surface to make smooth or even, level to make smooth or even by use of a plane. Um, to work with the plane, let me see.
Yeah,
Okay.
but what you need to now show,
Having
is measurements showing that all vertical lines define a plane the same everywhere.
so why is the horizon horizontal?
You asked it. I've answered the same question. I'm not going to answer it again. Just recall from remembering my
Just answer
answer
it
from
again. Just
before.
answer it again. It's
All right.
horizontal because why?
Because it's the limiting
Because
line of what you see on the surface of a sphere.
because why? Because why? On a sphere?
Yes.
Where does it say that?
You're asking me why the horizon is horizontal, and I'm telling
On
you.
a sphere? Where I've just read the definition of horizontal. It has nothing to do with a curve, a sphere.
Okay.
So don't you think that's a kind of a contradiction?
I think what you're trying to do is you're trying to use semantics as evidence, but that doesn't work because semantics is not evidence.
So the horizon isn't horizontal.
The horizon is
the horizon
curved.
horizontal?
The horizon is curved.
The horizon. Wait. So it's not horizontal.
It is curved.
So it's curved.
Yes, I said that. Did I say that? Pretty sure I said it. Chat, did I say the horizon? Did I say the horizon is curved, chat? So let me do a couple things here before we get too far in. Hippie, prove to me the black swan image isn't CGI. I don't think it's CGI, but that's fine. Listen, Kiwi wannabe, the black swan is dead and eaten. I'm going to bed for real this time later, everyone. Thank you, C4. The first one was from Jonathan L. Stephen, is it Stephen or Stefan Huxtable, has a sticker that says "Keep it up." William Foley for $5 says you can bring a flurf knowledge, but you can't make him think. And Brent Curry gives 5 New Zealand dollars, says, does he not know how big this earth is, and what will an ant see on a basketball? So
But
there we go.
yeah, well, you're saying you're seeing curve at sea level, so it's obviously not that big. Okay.
It is not too big that we cannot see curve from sea level. That's correct. So
Okay,
let me
so
pull up here.
the horizon. I'm going to read this real quick. The horizon or skyline is the apparent line that separates the Earth from the sky. The line that divides all visible directions into two categories: those that intersect the Earth's surface and those that do not. The true horizon is actually a theoretical line which can be observed when it lies on the sea surface. At many locations, this line is obscured by land, trees, buildings, mountains, etc. And the resulting intersection of the earth and sky is called the visible horizon. When looking at the sea from the shore, the part of the sea closest to the horizon is called the offing. The true horizon is horizontal. It surrounds the observer, and it's typically assumed to be a circle.
Okay.
The horizon, by definition, is horizontal.
Okay.
So it's not curved.
So is that a measurement?
That's the definition of the horizon.
Right, so is evidence for the shape of the Earth done through the dictionary, or is it done through measurements?
It's just saying that the horizon is horizontal.
Okay, but I'm asking a question. I'm asking a question. It's a very clear question. Is the shape of the Earth determined by the dictionary or by measurements?
Well, you have no geometry.
Hold on. Just a generic question. Is the shape of the Earth determined Through the dictionary or through measurements?
Well, you don't have geometry, so you don't even have a shape to the earth.
Don't go past the question. Just answer the specific question. Right? Is the shape of the earth determined by looking at the dictionary or by measuring the shape of the earth?
Well, when you see a horizon that's horizontal...
No. Just answer the question. Is the shape of the earth determined by what the dictionary says or by measuring it?
Well, it's more like the lack of measurement because you have no curve.
Just answer the question. Is the shape of the earth determined through the dictionary or by measuring the shape of the earth? I'm asking... No. Just answer the question.
What's the shape of the earth? You're saying
just
shape.
Answer
what's the shape of the earth?
Is it determined by measurements?
What is the shape of the earth? What is the shape of the earth?
Why are you so scared to answer the straight question? Is it the shape of the earth? No. I'm asking this question first.
I'm asking you. What's the shape of the earth? You're telling me to measure a shape.
I didn't. I'm asking if it's the dictionary or measurements.
What shape am I measuring?
No, you're deflecting from the question here, hippie.
I'm not. You're talking about a shape. What shape?
That's the question. Do we determine the shape by measurements or by looking at the dictionary?
I think we can determine the shape of the earth by looking at it.
Okay, by looking at it. Good. I'll take that. And measuring would be one of the ways to do that, right? And definitely not by just pulling up dictionary definitions, because if you want to just look at dictionary...
What are you measuring? What are you measuring?
Here's the deal. If you want to just look at the dictionary and
what
say...
What are you measuring, MC
Just a second. Measuring? If you're just going to look at the dictionary for the shape of the earth, then it's a sphere, because I have 40-some dictionary references that define the word level that are talking about the curve of the shape of the earth. Right here, level surface. Level surface, and here's the horizontal. You can see here on this one here, the curve right there.
So we see
that.
Ground. So we see that. We see that at sea level. We see that.
Hold on. You see here on the upper left where it has A. Just a second. Don't interrupt me, dude.
When do we see that? When do we see that?
Where I'm talking about whether or not the dictionary does these things, right? So you see up here at the top left, there's a letter A. You see that? And then there's a straight line that goes by A. That's the plane that's perpendicular to the vertical at that surface, right? And then we've got the curve, which is defined by surveyors to be level through A, right? So A is that line.
You're showing me a side-on view. You're not showing me.
Absolutely. But I was saying, anything. If you want to play dictionary games, I got some dictionary to show you here, right? But none of this is evidence for the shape of the earth, is it? All of this is
the horizon is horizontal. So you're saying that the horizon is horizontal? Is that what you're saying?
I'm saying that the horizon is curved and we can measure it.
But the horizon isn't curved.
Oh, but it is. So here, do you know who
How
Tommy...
can you measure it if it's apparent? How can you measure it if that line is apparent?
So, well, yeah, that's a good question. So what you want to do is find a time when there's less refraction. But the cool thing is
refraction.
Yeah, but you want to do it when there's not chaotic refraction events, right? So, but here's the thing about refraction is that it affects everything uniformly unless you have some crazy conditions, right? So you see here, this is a picture of the horizon with a straight edge in front of it, right? Now, when you take a picture with a camera, there's barrel distortion. And we can't trust the barrel distortion to tell us the truth about what's going on unless we can really, to a fine detail, quantify and eliminate or control the barrel distortion, which is hard to do, but you can get some rectilinear lenses and then clean that out, right? But here's what you do instead is you use a straight edge, right? So there's a straight edge here in front of the horizon. It's kind of hard to see, but I can zoom in here a little bit. And Tommy placed the horizon just above the straight edge here. You can see. Can you see that pretty well?
Yep.
and you can scroll right to left here and you can see the horizon. Now, that is hard to see at that level, but here's what I did. I spent some time and I counted some pixels. It took longer than I wanted. It took way too long, but I got some fantastic numbers. Let's see here. There it is. I put it all in Excel, and then I graphed it. Let me get it here. And I used Excel, and of course on my computer here I don't have Excel. I have numbers, so I'm going to have to show you on numbers, which does render it just fine. So here goes. I'm going to show you the. Oh crud! I will take a screenshot of this instead. And I can give you this number. All right, so there we go. That wasn't what I wanted to do. And I got some super chats I got to read after this too. So all right, let me grab and find the screenshot. There it is, new window. And here it is. There is on the line number there on the left, you see 1, 2, 3, 4, 5, 6. And then the pixel gap 10, 11, 12, right? And I measured every one of those gaps at a regular interval. And there is the graph of the horizon, measured and counted. Not much above sea level, and it's curved. So
what,
that's
the picture. That's curved right there.
So
that ain't curved.
This right here, quantified, right there, curved.
That picture doesn't look curved, bud.
It is curved, in fact. There's a graph. Sorry, not a graph. The actual formula for this is right here. Y equals negative 0.011x squared, which is a curve, plus 1.2991x plus 7.8737. So it is curved. It's not a strong curve, which is exactly what you'd expect at sea level, but it is curved right there.
You show me a graph that's got a curved line. That's all you're doing, dude.
So it actually is, and here's the raw numbers on the left side, the pixel gap that I counted, right, of this actual observation right here that Tommy did. And Tommy's in the chat. Everybody, thank you to Tommy for this excellent observation of a curved horizon. So
you think that's a curved horizon?
That is not just what I think to be a curved horizon. That is a scientific fact that it is a curved horizon. It's been measured and quantified, counted and graphed. Right there is a curved horizon.
Yeah, on your paper, that's a curved horizon.
And on the screen right here.
Man.
So,
I'm sorry, dude.
That is how science is done.
Are you okay, dude? Are you taking drugs?
That is how science is done.
Taking drugs?
You have a hypothesis. I have not taken any drugs. I do have some Dayquil in case I start coughing too much. But so far, just water for me.
I think you're taking drugs, bro, because there's no curve.
Here. Oh, all right. Well, everybody in the chat, looking at the screen here, do you see a curve on the screen?
That's a line that you drew or whatever on a screen. It's a
polynomial fit line.
So are you standing on that right now? Are you standing on that?
Am I standing on that?
Is that reality? Is that screen reality right there?
That screen is a measurement of reality. Absolutely. It is a measurement of reality. So, wow. I showed you how to take a picture of the horizon, controlling for the lens effects for barrel distortion, right?
Okay.
right? With the
how
straight
come?
edge that
How
we
come?
know is the straight edge. Now, if you don't like this measurement, here's how you refute science, better science. So if you do this, now I know in Colorado it's hard, Minnesota it's hard. Go somewhere, call somebody. Maybe you know somebody in Australia that does not live very far from water, and could get a straight edge that's 8 feet wide, and can line up the straight edge near the horizon and take some pictures for you, right?
Okay.
And then you could send that to me, send it to other people, and we can count the gap between the straight edge and the horizon to see if there is a measurable curve like there is on this one.
So, if you can see the curve at sea level,
Yes.
how come you can't see it when you get into an airplane?
You can. You
35,000
could.
feet.
Well, you can with the same measurement technique, of course, but you might have trouble bringing an 8-foot level onto a plane.
And how come Neil deGrasse Tyson says you can't see curvature at 128,000 feet?
I don't know. Are you debating Neil deGrasse Tyson?
No, I'm debating. He's
Very nice.
he's
So
he's
he doesn't.
he's famous.
He
So
doesn't
is he
speak
wrong?
for me.
So-
He doesn't
so-
speak for me.
So is
He
Neil
is
deGrasse
wrong.
Tyson wrong?
I do
Is
completely
is Neil
disagree
deGrasse
with
Tyson
him.
wrong?
I
Is
completely
Neil deGrasse
disagree.
Tyson wrong?
I'm
Why
answering
would
your
Neil
question.
deGrasse Tyson say
I'm
that?
answering your
Why
question.
would he say that?
I'm answering your
Why would
question,
you
so
say that?
stop talking. I completely disagree with Neil on this one. At 120,000 feet, I don't know why you would not see horizon curving. That makes no sense to me. I think he was talking about the GoPro lenses that they used in that, and the people make an accusation that the GoPro is showing the curve. So it would have been better if they had rectilinear lenses instead of GoPro lenses. But GoPros are cheap and they're rugged, and they have nice mounting brackets so you can put them on stuff, and you can buy 10 of them and put them on your thing instead of getting a rectilinear lens, which costs thousands of dollars.
So is that horizon that you say is curved? Is that the geometric horizon?
That is always the apparent horizon. But the nice thing is that it also controls for refraction.
So it's not a geometric horizon then.
Ninth time, we don't see the geometric horizon. We only see the refracted horizon. So the thing is, you need to control for that.
So that's not reality then. That's not reality then.
It is reality, of course.
If that's apparent, then it's not physical. You know, the physical world.
What you see
it's not physical.
is light, right? So if you're going to say it's not physical, then you're going to get into some weird version of science that nobody agrees with.
You're the one saying it's not physical. You're the one saying it's not physical.
I'm saying we see
and I'm agreeing with you.
The apparent horizon that's been refracted.
Exactly. What is an apparent horizon? It's not physical. It's a theoretical line.
It's
an apparent line.
It's an apparent line. Yes, exactly. So
exactly.
what you do when make
it's apparent, it's not physical.
So let me explain a little bit of things about science, okay?
So it's not physical.
Let me explain some things about science
not
to
physical.
you. Could you stop for a second and let me explain how science works a little bit? When you do observations and take measurements in science, you need to do things to control for conflating variables, right? So if you're on a ship and you're trying to measure,
what's your observation? What's your observation? What's your observation?
Explaining things. Hold on. When you're on a ship,
you're jumping to hypothesis.
And you want
what's
to
the
measure?
Observation?
Stop.
What's the observation?
I'm explaiing
what's
science to you, dude.
Yes, I'm explaining to you. You're skipping ahead to the hypothesis. Without doing an observation.
I'm not doing an observation. Can you have some manners and let me talk?
What's the observation?
Hey, Dandelion, could you talk to your man and have him teach him some manners, please?
What's the observation?
I'm explaining science to you. Okay? Here's what happens.
How are you explaining science to me when you can't even tell me the observation? Tell me the observation.
Stop and let me explain this to you. Okay? When you make an observation or a measurement in science, you need to control for conflating variables. If there's too many conflating variables, you can't make a good observation, right? So if you're on a ship and you want to measure the elevation to a star, and all you have is a astrolabe, it's very difficult to do because the ship moves up and down, right? So instead, they use a sextant, and a sextant has a partially mirrored lens on it, so that you can see both the horizon and the star at the same time. And as the ship moves up and down, the sextant moves with it, and your view of the horizon and your view of the star moves with yourself. So it controls for that movement. That's one example of how you can control a conflating variable. If you instead were just to use an astrolabe and just take a measurement while you're listing up and down, you're going to get a different measurement every time. So when you're looking at things through the atmosphere, you use previously known measurements of refractive hold on a second. Refractive conditions, like Gauss did when he measured at high altitude, from high altitude to high altitude, and he got a 1.13 coefficient of refraction. At lower altitudes, you use different ones, right? Or best, you actually take a measurement to get the refractive index so that you know the refractive index of your observation. Now, what was your question?
I said, what is your observation? You said this is science.
Okay,
What's
so
your observation?
The observation here of the horizon is the view of the horizon. Now, we know it's a refracted view of the horizon, but the nice thing is that the refraction is controlled because it's the same refractive index across the entire horizon.
So it's a refracted horizon. It's not a geometric horizon.
10th time, yes. So, but it's controlled, and so we know that.
How do ships go over something that's not physical?
I'm talking about this left to right curve here, right? So now on the left side,
if it's not geometric,
okay, I'm talking about this particular curve right here. On the left side of this observation, the coefficient of refraction is the same as on the right side of this observation, right? Both sides have the same refraction because they're taken at the same time. The middle, the left, the right, they all have the same coefficient of refraction. So we've controlled for that. So now any observation we make, we don't need to account for that anymore. That's how you control for conflating variables. So let's do this for just a second here.
That's not the geometric horizon.
There's no problem with that. You can still make perfectly fine observations with it if you can control for refraction.
You need a geometric horizon.
And
where's the control? Where's the control for the refraction?
The control for the refraction in this particular instance is that the entire horizon is refracted the same amount.
How do you know that?
Now, of course, there are conditions where it can potentially happen, but in general, the coefficient of refraction is the same in all directions over water. Now, the coefficient of refraction is going to be different over land than over water. Right? And people have measured that before. So, all right, so let's do this here. A fact, it is a spheroid boom, says, ask him, for $5, says, ask him to define level without telling what it is not and without using the word flat.
So you never see the geometric horizon. So you never see the geometric horizon, right?
11th time. No, we do not see. The geometric horizon. We only see the refracted horizon. That's 11 times.
So the horizon's not geometric.
12th time.
You need a geometric horizon. You know
no,
that,
you don't.
Right?
No, you don't.
Yes, you do.
Well, then make
ships don't go over a geometric horizon.
Present your proof that we must have a geometric horizon. They go over.
You need a geometric horizon. That's
okay. You have asserted that multiple times.
Does a sphere not have a geometric horizon?
You have asserted that we must have a geometric horizon many times.
Please support a geometric horizon.
Please
does a sphere have a geometric horizon?
The floor is yours to make your case.
Does a sphere have a geometric horizon?
Now, this is your chance to support your claim that we must
can you
have
not
a geometric
answer
horizon.
A question? Does the sphere have a geometric horizon?
Of course it does.
Exactly, but you're saying you never see it. So how do you know that there's geometric horizon if you never see it?
Oh man, this is way over your head, dude. I'm sorry.
How do you know that there's a geometric horizon if you never see it?
Because we can control for refraction.
How do you do that?
By taking measurements in different conditions and understanding what's going on.
But the horizon's always apparent. It's
Absolutely.
not geometric.
And we can control for that.
So how do ships go over something that's not physical? It's not geometric.
The light of the bottom of them is blocked by the physical water in front of them, and that light isn't refracted around it.
The physical geometric horizon.
The physical horizon, yeah, the surface of the water, for example.
So now there is
it.
So now there is a geometric horizon.
I'm sorry, this is just over your head. It is
no,
way
it
over your
seems
head.
to be over your head. You're contradicting yourself. You're saying there is a geometric horizon, but you never see it, but you know it's there because ships go over the geometric horizon. That's what you're saying. That's exactly what you're saying, MC Toon.
Oh, it's not that hard to understand, really. I think you're trying not to understand.
No, I know it's really not. It's really not that hard to understand. I agree. The horizon is not geometric.
Yes.
Welcome to Flat Earth, bud.
That's not how it works, though. So since the bottom of something is obstructed,
you're using our argument.
No,
you're using our argument to debate me, man.
Because here's what's not blocking.
We've always said that the horizon is not geometric. You guys say that it is, and then when we prove that it's not, you guys move the goalpost and say that it's not geometric.
Don't say you guys. You've only debated me once, right? So,
dude, you're saying right now you're saying that there's a curve, that there's a geometric curve.
Yes.
A physical
yes,
horizon.
Of course there is a physical curve. And we see only the refracted version of the horizon.
So it's not a geometric horizon.
Oh, dude, what's the count? I lost count. I should be like keeping track.
So it's not geometric. Welcome to Flat Earth.
No, that's not. All right, 13, 14 people are saying. That's not the thing, though. Here's what you're missing for Flat Earth. You're missing what is it that causes the bottom of remote things to be blocked?
Yes.
What is it that blocks things?
It's not being blocked.
The bottom of things are not being blocked?
Yeah, because there's no physical horizon. The horizon can't be obstructing anything if it's not physical.
So, well,
but you agreed.
But
you agree it's not physical.
But here's the thing: you're just not understanding the model.
You agree with me, MC Toon. You agree with me. No, you agree that the horizon is not physical. So it can't be blocking ships.
Of course it can.
Obstructing anything if it's not physical. So it is physical.
All right, so you need a little more math to understand this. I'm sorry.
So the horizon is physical.
The light is physically blocked from getting to us
by
at the bottom of the ship.
By what? The physical horizon?
The objects between us and the ship, for example. Yes.
So the physical horizon is blocking the ship.
Yes. The physical water in the way, for example, is blocking.
But the horizon is never physical. It's always apparent.
Absolutely. And both of these work perfectly fine together.
You just contradicted yourself, bud.
And I'm sorry that you don't understand. It's not that complex of geometry.
You have no geometry.
So
because you said you can't see your geometry.
Okay, so here let me explain. Maybe this can help. So coefficient of refraction. Hold on.
But there's no geometric.
I'm going to try to explain this to you. Just a second. Let me try to put it how you so can be understood better. Okay. The coefficient of refraction of 1 or higher means that the light will bend with a radius.
Bend around what?
A radius
bend around what?
Hold on, don't interrupt me. Bend with a radius that's less than the radius of the Earth. Right? So if the light comes off...
What's it bending around?
I had thought of the physical curve, of course. So let's see here. Here we go.
But you don't have a physical curve.
There's the physical curve.
You don't have a physical curve. You just admit it. You never see it.
Just because you see a modified version of it doesn't mean that that
What are you talking about? You're the one showing me a modified version. You're the one showing me a line that's curved on a graph.
all right. So here is, let's see, we've got over here the observer, and we've got over here an oil platform. So
So
the
So, are we looking at the Earth sideways, or are we looking at
this is an orthogonal. This is an orthogonal view of the Earth, right?
It's Muppet vision. That's exactly what it is. It's Muppet vision.
We're
Not. That's not reality, McToon.
this is a
It's
way
not reality.
this is a way to demonstrate and to draw it out. So I'm trying to explain it to you so you can understand. So let's see.
I understand perfectly fine, and I agree with you that the horizon is always apparent. It's not geometric.
All right. So we have a section right here. I should have had my my cam up. So all right. We have right here the surface of the water right here in this little section right here. And you can see here I say
share. I don't know if you're screen sharing or not.
Oh, hold on. I'll have to turn off my screen share. Yeah, you're not seeing my camera. Okay. So here we have an oil platform, right? And then right next to it, we've got this little section here, and I have this marked as K equals 1.2, right? So that means the coefficient of refraction, which is lowercase k usually, is 1.2. That means that the radius of the arc of the light will be less than the radius of the Earth. So it's going to bend tighter than the radius of the Earth. Right?
So
and then,
why do you have two,
hold on.
Why do you have two lines right there? Why do you have two lines right there?
So I'm just designating that this section here has a coefficient of refraction of 1.2, and then this section here, lines? This section over here has a coefficient of refraction of 1.0. This is a very simplistic version of it, right? But so the surface of the water. Stop interrupting.
Are those buildings on a geometric curve?
Of course they are. So the light bends tighter.
You have no geometric curve.
The light bends. Stop interrupting, dude. You're just like a little child. Dude, Joey's the worst, but you're getting there. Okay. It bends tighter than the radius of the Earth, and then for the rest of the path, it takes a 1.0, so it bends at about the radius of the Earth, right? And it makes it to our eye, even though it's on the other side of the curve. That light is allowed to get to us. This is my model. This is my model. Curve? There's a curve, and the light bends around the curve.
So there's a
physical curve.
It's bending over. It's bending over a geometric horizon.
It is bending over the surface of the water, which is curved.
The horizon, the curve.
Yes.
Right. So it's bending over the horizon.
In this particular drawing here, the surface of the water is being refracted with it. All right. So we've been on this for an hour. So hold on. Let's do some super chats and then move on. Right. So somebody asked you to define level without telling what it's not and without using the word flat. Can you do that?
Horizontal.
Level equals horizontal?
Yep.
You sure?
That's what I think.
That's what you think. Okay. Do you have any measurements to... forget about that. We'll go on. No Doubt for $2 says, Hip Hop Blimpy has gotten old yawn. Sorry, man. Let's see. RT96 says he has H3. That's you, H3. What's the shape of the atmosphere? Oh, see, he's getting in on the definition stuff.
Well, I say Anthony. That just because, just because that's what everybody says.
I know.
I would call. I don't really subscribe to anything sphere when it comes to the Earth, but whatever. I'll say atmosphere.
Like, what's his name? What's her name? Karen B. Anthony, I don't know how to say your last name right, so I'm sorry if I get it wrong. Secante? If science doesn't prove things, Why can't you admit you have faith in the ball tune? So, yeah, science does not prove things. Science gathers evidence and builds confidence. So, what I have is a large amount of confidence in the shape of the Earth. And I have, as when it goes to something like whether it's flat or not, or concave, silly concavers, I have no confidence in it being that shape. In fact, I have a high amount of confidence that it is not flat and it is not concave. So that's how it works. It's confidence, it's not faith. So, my goodness, there's a few. Dictionary says Roman Empire fell in 476 from Robert Williams. A good historian would then explain that only the Western Empire fell and the Eastern Empire fell in 1453. Good, I didn't know that. Point and laugh for $2.99 Australian. Tell him it's flat and move on to someone smarter. Oh, Hip Hop Hippie, you can be smarter. It's okay. No doubt doesn't.
You agree with me though. You agree that the horizon is not physical. So
No doubt has a adjective for you that is not polite. I'm sorry. Who's the one smoking something? John Rapford, 2 Australian. Hip Hop Hippie doesn't understand anything. Welcome to Flat Earth. Brent Curry, for $2 New Zealand dollars. Can you ask him if he knows how light works? Do you know how light works?
I'm gonna be honest. I don't think anybody knows how light works. I don't think there's a good enough theory for what light is. I mean, Neil deGrasse Tyson calls it wavicles, particles, and a wave simultaneously. That's just a bunch of nonsense. So
I suggest that you read some of the stuff by this guy here, Richard Feynman. He wrote some fantastic stuff on light, and he had a pretty good understanding of it. So, when a boat is traveling on the physical water and crosses the apparent line where the sky meets the physical water, is where the boat appears to disappear from the bottom up. For $10, fact is a spherical boom. Fact, it is spherical boom, says that. All right, let me read that again. When a boat is traveling on the physical water and crosses the apparent line where the sky meets the physical water, okay, passes the apparent horizon, is where the boat appears to disappear from the bottom up. There you go.
Yeah, it appears to disappear bottom up.
Yep.
But it's not because there's no physical horizon.
Yeah.
And you agree with me. You agree with me.
It's the apparent horizon. It is getting blocked.
It can't go over an apparent horizon because the apparent horizon's not a physical thing.
All right. So Ilya Moon for $5 says real planets have curves. Absolutely. They're much sexier than the flat ones. So, a Cretan Bull for $5 Monopoly dollars. Canadian dollars. Is the horizon physical or apparent? Is the new version of Who's on First? Oh, Anthony, are you whispering to me, hippie? Or are you talking to Dandelion? Anthony Sicante for $7.99 Australian. So are you admitting that you only have confidence? You aren't 100% positive. You believe in your confidence. I am extremely confident. And the confidence is bolstered, Anthony, that by having no contradictory evidence. All right. Punchy says Canadian money is perfectly acceptable currency. It is in Canada. If you ever take coins, Hippie, have you ever taken like a thing of coins to the bank and you dump it in the little change counter thing?
Mm-hmm.
We do that, like we save up for vacations that way. And then it kicks out on the little container at the bottom, some Canadian nickels and quarters and stuff. Like they don't want that. So maybe I'll bring them next time I go to Canada. So, all right. Well, how about this? How about we move away from apparent?
Do you want to get on the? I have another argument.
Oh, is it the same one?
Nope.
Yeah, that I would. It's rare to have flat earther really present much. So yeah, let's see what you got.
So, what about the sun? Can you explain why the apparent size of the sun
Never
changes
never
from
changes.
changes from noon to sunset?
Dude, you haven't
Can you
watched
explain
my
that?
you haven't watched my channel, have you?
I watched it.
Hold on. I love this video. And I love the Ooh. I'm gonna have to present to you. Just a second. You're not gonna see it just yet. All right, you see that? So this is the size of the sun viewed through a solar filter, which is the way to see the size of the sun. And these first three are by Felipe Rockholt, who is a flat earther. I love it. So there it is, the sun rising over Los Angeles. Look how full size that is. Oh, get the hands out of here.
So, are you gonna address what I said?
Yeah. I'm showing you how the sun does not change size throughout the day.
I'm asking you, how do you explain the apparent size of the sun changing from noon to sunset?
I am addressing that. So here's sunset with solar filter from Felipe Rockholt.
Are you gonna address what I said?
You've made a claim, and I am addressing it right now. You see it on the screen? The sun
Yeah.
does not change size.
Do you know who Dazzle the cameraman is?
I do. So all right, here's another one.
Okay.
So,
Well,
Z Milkus.
he made a.
Well,
Okay.
we'll go through this one.
Well, he did a video titled "Flat Earth Debunked: The Sun is Not Shrinking as
Yeah.
It Sets with a Solar Filter." And when you actually scrutinize the video, the sun does shrink.
Yeah, by how much?
From what I'm looking at least double.
Double. Excellent. Okay.
But can you explain why the apparent size of the sun shrinks from noon to sunset without the filter?
Without the filter, that would be because of glare.
That still doesn't explain. Do you have an explanation why that happens?
Yeah.
Why the glare?
Because the glare overpowers the sensor. The brightness of the sun overpowers the sensor. It's a pretty well-known artifact.
So you're saying that the sun moves into what? The sun moves, so it creates more glare?
It overpowers the sensors on the camera.
As it gets closer to the camera, yeah.
No, the amount of light is too much for the sensors.
Because the sun is moving closer to the camera.
No.
Yes. That's why the glare gets more intense, because the sun is moving closer towards the camera.
You mean midday
why-
it's closer to the camera than in the evening?
Like if you have a camera, just post it up
All right,
to watch the sun.
Here's the good one. This is Red's Rhetorics. All throughout the day, he took a picture every hour.
Can I send you pictures from Dazzle the cameraman's footage? Okay.
Geist
Yeah, he actually took down this video. He actually took down this video. Oh man, hold on one second here. Let's see. Give me a second and I'll send it to you, okay?
Okay. And look at that. Never changes size.
Well, I'm going to show you that it does.
Now, if the Earth were flat, then the sun would never get below 9.5 degrees above the horizon, which is a pretty big problem for flat Earth. Which if you've ever heard people say, I researched flat Earth and I couldn't debunk it for 2 years and I finally had to admit it or whatever, that's about everybody's same old story. I thought about it for 3 seconds and debunked it. The sun would never set. Then I did the math. 9.5 degrees, the sun would never set.
Yeah, it would. Perspective.
In fact, I calculated perspective. 9.5 degrees. Because you can calculate perspective. It's not that difficult. If you need about 8th grade math to be able to calculate perspective.
Yeah, you don't even take perspective into your geometry though.
I actually did. Yeah. When I calculated perspective of what you would see with the sun.
But you don't have geometry because you don't have a geometric horizon.
Oh, you're back to that one again, huh? So the sun could never set.
Yes, it can. You just don't know. You don't know. Sorry, dude. You really just don't know what perspective, how it works.
Well, I'll do the math here. I'll show it to you, and then you can show me what's wrong with my math. So here's the deal with how depth perception works. Right? Do you see this?
Yep.
Right. So everything above goes down, but never crosses to below. It just, as it goes farther away, it appears to go farther down. Right?
It does though. It does. It appears to go below.
It appears to. But perspective doesn't bring something below the midpoint, and something as it goes farther, it goes.
The sun never goes below our feet. It's and that's what you're saying. You're the one saying that the sun does go below the horizon.
So all right. So I'm just talking about perspective here, right? You see it on the screen. Something as it goes farther away, it gets farther down, closer to the midline there, right? And everything to the left moves to the center, everything to the right moves to the center, everything below moves to the center. But never does anything below cross the center and appear above. Never does anything from the right side cross to the left side. Never does anything from the top cross down to the bottom, right? That's perspective as it gets farther away.
Yep.
All right. So the sun's angular elevation, so we can just calculate that. With a triangle there. You see that?
Okay. I'm sending you an email.
All right. So I'll go through this here. So I'll go right down to Minneapolis on the northern solstice, which would be in the middle of summer here.
It's not my map.
Oh, what's your map?
It's not my map.
What's your map?
I don't have a map.
Oh. Well, then you don't have anything. How do you not have a map? Do you not know that people fly and take boats all over the world all day, every day? They get there somehow. There's a map.
Yeah, there's a map, but that's not that one right there. That's not my map.
Oh, well, what's your map then? Send it over and I'll examine it.
I don't have a map.
Well, then you don't have anything. Why are you even talking to people about this? You don't even have a map. That's ridiculous. How do you not have a map? Dude, you can't be serious. Are you just a Poe? Everybody.
No, I don't.
People were saying. All right, let's go back to this here.
I don't know how the Earth is laid out.
Andrew Brooks. Andrew Brooks. Where did he say that? We all know he's a Poe. So if you don't have a map, you don't have anything. Do you think the sun does circles around the North Pole?
I don't know. I have no idea what it does.
goodness.
I
You
just
have,
know I
you
just
have,
know it moves away from me because I see it move every day, every single day. I see it
yeah,
move
yeah,
from
but,
east to
but you,
west.
wow. What a
That's
shame.
all I know.
What a shame.
Did you get that
I,
email?
I wish I had some alcohol. I have to break my rule.
But that's we can get back to the sun. Yeah,
All
Dazzle
right,
the cameraman.
I got a 9:45 p.m. email from you. Where is it? Oh, those pictures. Okay, hold on. Man, that's a letdown. No map.
It's fine. I don't have the time to make a map. If I had the
Oh,
resources and
it's not that
know
hard.
how, I would do it.
It's not that hard. You just take angles. All right. So we got the first one
So
here.
they created all maps just from angles. They didn't like sail
Well,
anywhere.
you can do that, but yeah, of course they use all sorts of things for cartography, but you can get some basic ones just by looking at angles. So
I'm just
all right,
saying if I could do that, then yeah, I would give you a map. But I
all
don't
right,
have the
Bendy, you
time or resources
gotta
to do
send
that.
me some of that shine. I don't drink either, but are closer and closer to start. Yeah, I've been meaning to start. Oh. All right. So this Daz the cameraman is the sun is not shrinking as it sets. Okay.
There you
Yeah.
go.
But but is
And that's
this
using a solar filter. And
this
Dazzle the
is
cameraman took down that video. He
yeah,
took down that video
this is
because
not with
he
the solar
realized
filter.
what it showed. It's with a solar filter.
That's no, the solar filter doesn't, that's glare.
Where's the blue sky if that's not a solar filter?
Solar filter doesn't show you blue sky.
Uh, no, I'm saying where is the blue sky if that is not a solar filter?
It's the oh my gosh. All right.
Because it's a solar filter. He's using a
I
solar
know.
filter.
I know Daz the
What
cameraman.
is the sun up during the night?
This the sky isn't always blue, man. You've never seen a sunset.
I have I have other uh I have other sunsets where the sun doesn't set from DRTRH.
Oh, let's call it right. Dearth.
Yeah, I call them girth too. But I also have I also have two other videos to
Oh,
show
this
you.
isn't. All right, hold on. That's the wrong. So you say he took this down. So let's check this. And I know him. I can ask him what's going on with that, and we can get the actual information on it. Since all you have is screenshots of it, that's a little difficult,
Yeah, I know.
right? So how long ago was it?
No, let's say a couple of years ago. I don't know. Does it have the date? It might have the date on there.
No, I don't see it there. It's a pretty blurry screenshot too. So all right, hold on. I'll see if.
Yeah, it was a screenshot from a Southern Israelite, and Southern Israelite pointed it out to him that the sun was shrinking, and he took the video off
Yeah.
the YouTube.
So yeah, I don't see it. Tell you what, I will message him. I'll do it right now.
Okay.
And Daza. Hip Hop Hippie says you took down a video.
It's kind of funny why you would take down the video. I mean, why take it down? It could debunk Splat Earth. I also have two other videos to show you.
Yep. All right. There we go. Sent it to him. We'll find out. All right. Dazza used someone else's video who used sunglasses lens to point out why they were wrong, if I recall. Nice. It's not Daz's video. That's some video someone else made using a neutral density filter. They tried to spin it as Daz's. Nice.
That's the cameraman's channel, though.
It is, but if he was addressing somebody else's video, so we'll get the answer to that. All right, I don't know if he'll answer right now, but we'll get the answer. We can come back to that one a different day, maybe, right? But of course,
why would it shrink?
And as I said, this does not appear to be a solar filter because the edges of the sun are blurry. A solar filter makes it very crisp, as you saw in. Oh, come on.
It is.
Goes right for an ad. Here we go. So here is a sun in a solar filter. Crisp edges, very crisp edges. And the background is black because nothing else is bright enough to get through except for the sun.
So how do you explain the apparent size shrinking without a solar filter?
Glare. That's easy. This is just the basics of photography.
That's what I'm saying. The sun gets closer to the camera, which causes more glare.
No. Oh, you mean like when it's
camera,
when it midday versus on the horizon? Midday versus when it's low in the sky, right?
Midday till sunset.
Yeah. Okay. So why can we not see the Burj Khalifa if the world is flat?
Perspective.
Perspective doesn't block things.
Things get smaller in the distance. You're not gonna.
But if you're high enough,
everything gets smaller in distance.
Say you're on the top of Mount Everest and you pull out a telescope and you point it towards the Burj Khalifa. Why could you not see the Burj Khalifa?
Because of perspective.
No, you get a really good telescope. Really,
so you're pretty much saying,
telescope.
if you had a strong enough telescope that you'd be able to look all the way around the globe back to see.
Not the globe.
The back of your head.
Not the globe. The flat Earth, right? This is flat Earth, right? So if you're at the top of Everest, let's say we're on the top of Burj Khalifa because they could put a telescope there. It's hard to put a telescope on the top of, hold on.
Perspective, man.
It'll make it smaller, right? But you get a bigger telescope, bigger telescope, right? So could you see with the big enough telescope? Could you see from the top of the Burj Khalifa all the way over to Mount Everest?
I don't know.
You don't know.
I don't have a telescope like that.
Well, you don't need to have a telescope. Do you think you could? Do you think it would be possible?
I have no idea. Maybe.
Oh, man, you're just a letdown again today. All right. So here's why things get less bright later in the day, because there's more atmosphere for it to go through. This isn't that complicated.
The sun is moving, so the glare is shrinking.
Yeah. So now, what measurements have you taken to find out the distance to the sun?
I don't know the distance to the sun.
So you've not taken any measurements?
I never said I knew the distance to the sun.
Oh, well then it's 93 million miles away? You're fine with that?
It can't be 93 million miles away because it's right there. You could see it.
Well, yeah, but you could see it if it was 93 million miles away too.
It's moving.
But what if we're rotating, right? Let me just I'll just spitball this here, right? Let's say let me get some tab here. Let's say we're sitting on this thing here, right? And the sun is right there, right? You're the sun, right? And you're far, far away, right? And right here, you're here, right? And you can see the sun.
I can't see you. Tim, you gotta screen share.
What kind of amateur am I? My goodness. All right, can you see me now?
Yep.
All right, so here we go. Here's the sun's there. Your eyeball is on the sun, and this part right here is let's get some land right down here. Right, you're in, where's that? Ecuador, right? And now here's what's going to happen. It's going to rotate, right? And now it's on the horizon. I'm looking through lots of air to the sun, and now there's something in the way, right? Now that's one idea for how how it might work.
But you don't have a physical obstruction. So
You do, but it's affected. Your view of it is affected by refraction.
how do you know you have a physical obstruction when you say you can never see the physical
Because you can
geometry?
control for refraction. You can control conflating variables. That's like I said in science, you do things to control conflating variables. So really good is to try to either, if you can't control for refraction when you're making vertical measurements, you make horizontal measurements because refraction doesn't affect it. A little, but not nearly as much. It's a significantly smaller amount. Daza wants the link.
Okay,
So,
I sent you another video of the sun shrinking.
all right, hold on a second. I gotta do Geist View. I will send you this. Seems like Geist View is talking to Daza, so we can get to the bottom of this maybe today. That would be super. All right, and now you sent me some email. You sent me a Facebook video.
Yep.
Okay, hold on. Guy with some name that I can't pronounce. All right. I don't know. Let me see if I can watch this incognito. Yeah, it works. All right. So now, is this going to be a solar filter? Because if it's not a solar filter, I know exactly what's going to happen. Right.
Okay, well, let's swap it.
All right, hold on. I got to present it to you so you don't see my stupid face. You instead see... There it is. And then the viewers get to see it as well. There we go. All right. So here is the non-solar filter. So yeah, it doesn't have a solar filter. So yeah, if you want to do a crap observation again, which is what flat earthers tend to love to do.
How do you explain that? How do you explain that? You don't need a solar filter to explain that. How do you explain that?
More atmosphere getting in the way. This is basic.
So you think? Look at that, man.
Sorry.
Mm. It's pretty damning.
That is completely predicted on the globe. So I don't know why you'd think that's anything unusual.
I sent you another video of the sun shrinking.
Yeah, is it another one with oh, go away here.
You know how you explain that, MC Tune? The sun is moving away, so the glare is getting less and less. That's how you explain that, McTune.
All right, so hold on. Again, this is basic photography. I'll show you this one
Play it
here.
again.
This is basic photography. As the sun has more atmosphere that the light is going through, its intensity is reduced by that. That's basic photography. I don't know why this is.
It's showing you the sun moving away. It's getting smaller as it goes away.
It's getting more air in the way.
And look, it disappears before it even hits the horizon.
Are there clouds in the way?
Because it's moving into the atmosphere.
Yes,
it's not going behind a curve.
That one was clouds getting in the way. So
that just showed you the sun moving away. That's how you explain that, McTune.
The
sun is moving. You see it every day. Are you denying that the sun moves from east to west every day?
Hey, Daza,
are you denying that? Are you denying reality again?
Daza, could you message me on Twitter? Or
are you denying that the sun moves from east to west every day?
No, I'm denying that it's getting significantly different in distance.
So the sun. So you're not denying that the sun is moving. So you're
So
saying the
the
sun is
sun
moving.
moves, the earth moves, we all move. But what we do is we sometimes set a reference frame. So typically what we do when we're talking about the earth and the sun relationship, we fix, it's a sun-centered, sun-fixed reference system, right? So we imagine for a moment that the sun is fixed and it's not rotating around the galaxy and all
But
that.
that's not your
And
model,
then the
McToon.
sun,
That's not
that is the model, is moving around.
Your sun is not fixed, though, McToon. Your sun is not fixed.
Yeah, but
Your
this
sun
is
is your sun is orbiting around the great attractor. You don't even believe in the heliocentric model.
no. Here I'm
You don't.
explaining the
You have
geometry
multiple
when you do
models.
when you do calculations and have discussions about it, right?
So the heliocentric model, the sun is not moving.
No,
It's fixed.
you've got to
Everything
listen.
rotates around the sun, but
You've
that's
got
not
to
the truth
listen
because
for
the
a
sun is
second.
rotating.
You've got
That's
to
not the
listen.
heliocentric model.
What we do is in order to have a conversation about it and in order to do math about it and model it, what we'll do is we will temporarily assume that the sun is fixed so that we can model around the sun being
So we have to, we have to, we have to, we
planets
have to,
moving
we
around
have
the
to, we
sun,
have.
right?
So we have to assume.
And
We have
then
to
when you're like,
assume
oh
it's
well,
fixed.
we want to
But you can
expand
see the
and
sun.
explore a different version of our yeah, Daz.
How are we going to assume? How are we going to assume the sun is fixed when we see it move from east to west every day?
That's
How can you assume that it's
the
fixed?
Earth rotating. So all right, so
Well,
Dazza the
that's another
cameraman
assumption.
is ready to come on and explain this observation. But Dazza, if you could send me an email, mctune@mctune.net, or you could send me right in Globeheads on Twitter. There, I could send you that there because I think you're in there, right? Hold on.
So you're saying the sun doesn't move from east to west every day?
Oh, Dazza, you're not following me back. So I will send a message in. I can send a message in that group chat. Just a second, man. Hey, calm down. Calm down, hippie. There you go, Dazza. It's in that Twitter group. All right. So when we talk about the Earth rotating and the sun setting, oh, there we go. I've got this. Is my wife got this this little thing.
But we're not talking about
Christmas.
the Earth.
So
We're not talking about the Earth spinning. We're talking about the sun moving.
we're talking about what we say colloquially is that the sun sets. Of course, the Earth is rotating, not the sun setting. But that's just what we call it for conversation's sake.
But you see the sun move, McToon.
It
Are you
does
not
appear.
seeing the
It
sun
does
move
appear
east
to
to west?
us to move. Exactly.
Exactly.
It does appear.
And that's just a crazy coincidence, right? That in our view, the sun moves. But you call us crazy because we think the sun moves, and you agree that it appears to move.
Yes. And
So how are we
nothing wrong
crazy?
with that.
How are we crazy if
Well,
we see the sun move?
The crazy is when you reject the measurements of the radius of the Earth. So
Well, you're the one who says there is no radius, that the radius changes. It's not a set in stone radius because you say the radius changes because the horizon changes.
hold on a second. I'm sorry. I was flat Earth. Oh, from sun put into perspective. Oh, from Sean Hufford. So Daz is coming here for a second. Sorry. So I'm sorry. I didn't quite catch what you said last. What was it?
I can't even remember, dude.
Must not have been important.
I'm saying you agree with me that the sun is moving because we see it move every day.
The
we
sun,
see it move
the
every
sun
day.
moves around the solar system or around the galaxy. Yes.
But but doesn't the heliocentric model say that the sun is the center?
It does, yes.
So how is it's not the center though, it's moving around the great attractor.
Yes.
So So that's not the heliocentric model.
Sure it is. Sure it is. So what we do is for calculations, we do things to simplify things. So Daza, it looks like I don't know if you want this,
Okay.
your full name
So
is
okay.
just a
Can,
second. Hip
hold
hop
hold
hippie.
on, hold on,
I'm
hold on, hold on,
speaking
hold on, hold on,
to
hold on,
Daza.
please. Hold on 1 second. Sorry, Daza. So you're saying that we simplify we do models to simplify things,
Yes,
right?
yes, we do.
To make things easier. How come the government, all their models are flat and stationary Earth models?
They're simplifications as well, of course. So all
Yeah,
right,
because the flat Earth
Daza,
is
it
more
has.
simple.
Hold
It's
on,
easier.
hippie, quiet.
Makes
Daza,
more sense.
all right, Daza, it has your real name there visible. I don't know if you want that or not. And you're muted so far, Daza. So
Okay, can you hear me now?
I can, yes. But
Hi there.
it's showing your real name, and I have it off screen
Okay.
right now. Is that okay?
Just looking, where can I see that?
You wouldn't right now.
Is it my actual personal name or?
Yes, it is.
That's fine. That's no problem.
Okay. I just wanted to make sure. All right, hippie. I muted you just so I could talk to Daza here briefly. So, I'm gonna. So you have to unmute yourself in order to speak again, hippie. So, and I didn't mean to do that. I just had to do that little bit of logistics.
To get.
That's fine.
So, all right. So, welcome, Daza. So Hippie had some video of yours that he said showed the sun changing in size, and he claimed it was a solar filter, and I thought it looked like it was not a solar filter. And did you see that what he was doing there?
No, I've just been alerted to the discussion, so I didn't see it. I recall the video referred to, and I will be the first one to admit that I didn't scrutinize the video well enough.
Okay.
Okay, and on closer inspection, I did see that there was a slight change in it. But clearly, we can see, looking at the video, that it is not properly filtered. Now, having said all of that, if you go to my channel and look in my playlists for Flat Earth and other playlists, you'll find that I've created a number of videos where I have properly filmed the sun using a proper solar filter to reduce all of the glare or to eliminate all of the glare. And we clearly see that there is no change whatsoever as the sun crosses the sky. If you don't use a filter, then you're going to get glare, and the glare does reduce as the sun approaches the horizon due to the thicker atmosphere. Obviously, when we're looking pretty much horizontally through the atmosphere, we're looking through considerably more atmosphere than when we're looking up, say, at a 45-degree angle.
Hippie, you're muted again. I think you muted yourself or something. Because I didn't. Well.
So you agree that the glare does shrink?
The glare itself shrinks, but the glare is not the sun. You can clearly separate the difference between the glare and the sun when you use a proper solar filter. In fact, if you go to the hardware store and spend about $2 and buy a number 14 grade or darker solar welder's lens, you can use that as a solar filter, and you can clearly see the difference between the glare and the actual size of the sun itself, or the apparent size. And it is very small. It's approximately half a degree. I've posted photos, and I've included these in some of the videos that I've uploaded, showing a comparison of the sun with and without filtering. And the sun without the filter looks considerably larger than it does with the filter.
Okay. That's fine.
So I have.
No
Can I ask
problem.
you a question, Hip Hop?
Yeah.
Okay. I'm sorry, I'm not familiar with your channel, if you have one, but can I ask you, have you actually done any experiments yourself where you have filmed the sun crossing the sky using a suitable solar filter?
No.
Do you have a camera that you would be able to use to do such an experiment?
Nope.
Okay, that's a shame, because what I would encourage you to do is actually get a filter and try it for yourself, and you will find that what I'm telling you is exactly true.
I know. Well, yeah, that's fine. What I'm saying is why does the glare shrink?
Okay, so we're looking at the sun through the atmosphere, and I'm sure that you'll understand that the atmosphere dissipates light. That's not really the word I'm looking for. You've sort of got this opaque effect with the atmosphere. I'm just trying to think of the right word that I'm looking for.
It reduces the intensity. It absorbs.
Well, it does that too,
light.
but sorry, it scatters the light. Okay, so as the light is coming from the sun, and I'm going to refer to it as the disk of the sun, and I'm going to say, I'm not suggesting that the sun is flat for any moment, but for all intents and purposes, when we look at the sun, it looks like a disk. So you've got a confined sort of circular shape to it. So that light coming from that very defined disk, as it comes through our atmosphere, is scattered. And this is what you see. I encourage you to go to the hardware store and buy a replacement welder's lens for about $2. As I say, grade 14 or darker, or 12, I think it is, or darker. And hold that up and look at the sun through it, and you will see all of that glare suddenly disappear, and you will see the actual size of the sun's disk without all of that glare. And you will be surprised at the significant difference in apparent size. When we see the sun in the sky, we think, oh, the sun's enormous. You know, you see all of that glare and you think it's all the sun. But when you use a solar filter, you will be surprised at how tiny the sun's disk is in the sky.
Yep. Okay.
Okay, so any more questions about the glare?
Nope.
Great. I'm glad that was simple.
All right. Well, thank you. We're getting almost to the 2-hour mark, and I do have a second debate lined up with both Jack Zhang, and he has a guy, Godwin, and I'm just going to moderate that. So, Dazza, thank you very much for popping in. I appreciate it very much.
You're welcome, and I'd be very happy to clarify anything else about that video or anything related to it.
Yeah, thank you.
Yeah.
And Hippie, we got a couple minutes left. I'll see if there's anything. Let's see. Real planets have curves. Somebody said, let's see. Cretan Ball, is the horizon physical or apparent? Is the new version of Who's on First? We got that already. There you go. Here we go. We've got Esteban Ilbaca. I hope I got that right. For 2,500 CLP currency. I don't know what that is. He needs to get, you don't see physical stuff. We see the light bounced off them. Apparent does not mean we don't see the real thing. Yep. Point laugh for $2 Australian. Sun changes size when you observe it at night. It's hard to see at night.
Yeah. If you've got time, I wonder if I could ask a question for Hip Hop.
We've got a few minutes, maybe 5.
Okay.
Yeah.
Is that all right, Hip Hop?
Yeah.
Okay. So I assume that you are a flat earther who believes in the flat Earth model, if I can generalize there. Is that correct?
No, I don't have a model.
Uh-huh.
Subscribe to.
Do you believe that the Earth is flat or not?
I don't know the shape of the Earth. I'm a bumpy earther.
Uh-huh. Okay.
The Earth is
So
bumpy.
He has
Has
no
mountains.
map. He has no map. It's kind of a letdown.
yeah. So you don't necessarily subscribe to the flat Earth idea that the Earth is a flat disk with the sun and the moon sort of rotating around in a circle above the flat Earth.
Yeah, I don't know like what path the sun takes. I don't know like the exact path, but I think the sun is moving. I
Okay, all right.
I could see
Well,
the
well,
sun moving, so to me it makes more sense that it's moving because I could see it moving than me being on a ball that's spinning.
right.
Because that,
Okay,
that that means that the sun is stationary in the sky, and that we're
right.
we're
Okay,
moving.
well, since we can't sort of really define what it is exactly that you think the Earth is, and how the sun works and all that sort of thing, then my question isn't probably really relevant for you anyway.
Okay.
All right.
Sorry.
Well, thank you very much, both of you. You're, of course, welcome to stick around. Jack Zhang said you're both welcome to stick around for the next debate, but it will be between Jack and Godwin. So, or Godric, I think so. And I do need to. I'm gonna have to wrap this up and get ready for the next one. So, thank you both of you for coming. If you liked this video, like and subscribe if you're interested in talking with Hop Hippie. I expect that he might be active in the comments here. Please be kind. He was very polite, and I think we had a nice talk, other than a couple times he wouldn't let me talk, but that's all good. So, yeah, Hop Hippie. Why does the moon appear larger on the horizon? Somebody's, Martin H is asking.
Well, I'm assuming refraction.
Refraction. So
Oh,
actually, try
As it
this.
gets down lower to the horizon, there's going to be more. It's going to be, there's going to be more air that you're looking through.
Try
So-
this next time. Get your pinky arm length like that. Close one eye and look how wide the moon is when it's right on the horizon, and do the same in the middle of the night.
So what's your explanation?
or better still, take some photos.
What's your explanation? Why is it bigger on the horizon?
My explanation is, sorry, got water in my glasses. It's not. When you do this on the horizon, you do that in the middle of the sky, it's not actually bigger. It's just an optical illusion that our eyes play on us.
Oh,
Exactly.
So it's really not bigger then.
Exactly. It's really not bigger. It's the same size. Mid night when the moon is in the center, and on when it's on the horizons. So,
Can I just comment on that?
yeah.
Okay. The reason for this hip hop is because when the moon is down near the horizon, and you're looking at the horizon, often you've got familiar objects such as trees or distant buildings. Distant buildings are really good because you've got rooftops and so on. So to your mind, you're comparing that moon to the size of those distant buildings. When the moon is up in the sky, you've got nothing to compare it to. It looks a lot smaller, but when it's down low and close to those distant buildings, the moon against those rooftops or those distant buildings or the trees looks enormous. But as I say, if you're actually to take some photos of it with a good zoom camera, such as P900 or whatever, and make sure that you're using the same zoom each time you take a photo, you will find that the photos, the size is exactly the same. The only caveat to that is that sometimes when the moon is right on the horizon, there is some squashing which occurs, which is in fact due to refraction. But you'll find that the width of the moon is exactly the same as it was when it was high in the sky.
Okay.
Very nice.
Don't really. Okay.
Give it a
Thanks.
shot. Use your pinky at full arm's length, and it should be about half the width of your pinky. So, all right. Thank you, everybody, for coming. And be sure to stick around for the next one, which I'm going to close this stream and do another one, and we'll get the link in the live chat here. So thanks a lot, everybody, and we'll see you next time.